Okay, so now we have reached that part of the AMC where we're talking about sequences and series. Okay, perhaps I believe one of the more favorable topics, at least for me, is really dealing with patterns in numbers or number patterns. Okay, and you know what we're going to do with them, whether we multiply them, we add them up so that we get a desired result. Okay, now I must also say that this sequences and series is really a starting point of a much greater field in mathematics, which is called divergence and convergence of series and sequences. Okay, so you know, all good. I mean, it's good to know at least something a bit about it and to solve problems about it. Okay, so we got sequences and series, and as a start, I would really like to just clear things up. Okay, I'm not too sure whether teachers or books do that, but I would really want to do that. Okay, so what's the difference between a sequence and a series? Okay, formally stating, a sequence is a function, okay, that assigns a value to a certain integer, okay, and usually that function is defined as an. Okay, now let's just say 3n take away 2. Okay, this would be the value that we assign to the integer, and the integer is basically the n integer over here. Okay, this is the function. So this integer also tells us about the term of the sequence. Okay, so a sequence basically, okay, will give us a line of numbers all corresponding to this function. So what is the first term? The first term is a1, we just simply get 1 over here. The second term is a2, 2 we get 2, 6 divided 2 is 4. So this is the sequence that we get, 1, 4, okay, so on and so forth. I believe it's 7 and so forth like that. But basically this is the function that really spans the sequence, if one might call it that way. But bear in mind that a sequence is really just a set of numbers that is defined as the first term, the second term, the third term, all the way to the nth term. Okay, so that's a sequence, fairly easy. Now a series, okay, is what we do with the numbers in the sequence. Okay, in a series, we are just basically adding up all the terms in the sequence up to a certain integer. Okay, so it will just be basically, we will write it as Sn. So basically the series up to the n integer is equals to the first term, add up with the second term, add up with the third term, all the way to the n term, like so. Okay, this is what a series is. We are adding up the terms in the corresponding sequence. Okay, just basic definitions, or to clear up the difference between a series and a sequence. Okay, so now moving on to more meaty stuff. In the AMC, you would have two big families of sequences and series. For purpose of discussion, let's just call them series right now, because more of the time we're adding them up. Okay, so two big families of series, and that is the geometric and the arithmetic. Okay, for this part of the video, we're going to talk about the arithmetic series. Okay, now what is the arithmetic series? The arithmetic series, okay, comes from a sequence that is defined by this: an is equals to a plus n minus 1 d. Okay, I hope you can see that. This d over here is called the common difference. Okay, and the a over here is called the first term. Okay, now looking at the form, basically is that the numbers in the sequence, okay, the number over here, the number over here, the number over here in the sequence is separated by the common difference, okay, which is d over here, like so. And we normally add d to get the next term in the sequence. Okay, now why is that so? Well, basically we just substitute the values inside here. A1 we get a 0 over here, so we just basically get a, which is the first term. No surprise about that. Okay, A2 we will just basically add up 1d. Okay, I mean we add up 1 times d. Okay, and then A3 is equals to a, add up with 2 times d, which is basically add up 2 common differences from the first term, or 1 common difference from the term that is preceding it, A3 over here. So basically, just think about that the number in the sequences are separated by d, the common difference. Okay, now that is the function of the sequence, which should be easy enough to understand. However, what we really want to find is that we want to find a series. So what we get when we add up all these terms together, all the terms together, and that is an equation that we need to derive, and we'll derive it now. Okay, so the series, okay, by the way, okay, this is called an arithmetic. Okay, arithmetic, I think it's series, or there's another term which is called a progression. Okay, and as long as you see the word arithmetic, just bear in mind it's a common difference relating the two terms. Okay, so now we want to find the series of the arithmetic series, okay, which we know as Sn. So what are we finding? we are finding that, okay, I will just, for illustration's sake, okay, so let's just say the sequence is like that, right? So we do a first term, second term, third term, fourth term, fifth term, okay? We want to find a series such that when we put in the value 4 inside the series, okay, we immediately get the sum from the first term to the fourth term. Okay, now I understand that we can get the sum by finding A1, A2, A3, A4 and then adding them all up defined by the function over here. That is fine. But we want to do things quick. So we want a general formula such that when we put in the integer, or at least that term that we want to find the sum up to, okay, we can immediately get it, okay, and that is what we're going to do right here. We are going to find the series, okay. Another term for it, which if you want to understand better, is the sum up to the n term, right here, like so. Okay, so let's do this. So basically it's a1 plus a2 plus all the way to an, correct? So basically we are finding the sum up to the n term. Now we can immediately substitute the function which defines the sequence, okay, which is a and take away 1, sorry, this would be a, okay, plus a plus b, okay. Remember the second term is we add one common difference plus, okay, a plus 2d, okay, all the way to an. But what is an? An is the one over here. So the first term plus n take away 1d. Okay. Now we don't know what the value of n is, so that's why we will just put it in its general form. Now the ellipsis, I think that's what it's called, when we just truncate it. Okay. Now what can we recognize? Now there's up to n terms, right? So basically the first term a would appear n times. I hope you can see that. There are n terms. For each of the term there's the a inside, so the a appears n times. We will put like this, plus, okay, now this is the second term already, right? And there's a d, okay? So it's basically plus 1, right? 1d, plus 2, I got a 2 over here, plus, okay, all the way to n minus 1, okay? I'm just factoring out the d. Okay, bearing in mind that the d does not occur. The d does not occur for the first term. Okay, so this one is the one that I get over here. Okay, so now it's a matter of really finding this sum over here. Okay, which we need to prove separately. Okay, so but it's very easy to do. Okay, so basically let's just say okay, excuse the notation. En is equals to 1 plus 2 plus all the way to n take away 1, okay? Now, I'm going to rewrite it again, okay? And I'll put en, okay? But this time I will put n minus 1 plus, okay, there should be n minus 2 over here, okay? Sorry, okay, I'll just clear up the algebra. Okay, never mind. Plus 3 plus all the way to n minus 2 plus n minus 1, okay? I will rewrite again the same series, okay? So basically we just want to find 1 plus 2 plus 3 all the way to n minus 1. What is the sum, okay? So I'm just rewriting it again, okay, backwards. Plus all the way to 3 plus 2 plus 1. Okay, now looking at these two, I can add them up, right? But why do I want to add them up? Because I noticed carefully that there's something common if I pair up this term and this term, this term and this term, and this term and this term, likewise this term and this term, this term and this term over here. What is the thing that's common? Well, n minus 1 plus 1, what do I get? N, okay? n minus 2 plus 2, what do I get? I will get n, okay? And likewise for for the starting 1 plus n minus 1, I also get n. So basically, all these terms would give me n. They kind of, in a way, cancel out each other, okay? Roughly speaking, they cancel out each other, okay? So I will get n. However, how many times does it occur, okay? It occurs, 1 is the first term, the last term is n minus 1. It occurs n minus 1 times. There we go, okay? Now, I just divide, so en, the separate series, is equals to n minus 1 divided by 2. Okay, this is en over here. This corresponds to this parentheses over there, like so. Okay, n times n minus 1 divided by 2. So we will just quickly write this as n times the first term, n minus 1 divided by 2 multiplied by the common difference d. And there we go, the series, the sum of an arithmetic series, okay, which is the one over here, like so. Which another way that we can write it, okay, rearranging, we get n divided by 2, 2a plus n take away 1d. Okay, and before I wrap up, I will just show you another form which is highly useful. Okay, knowing that these are the two forms like so, right? Okay, so basically this tells us that pick a term in a sequence, put in the value of n inside, you immediately get the sum, okay, which is defined like so. Notice, let's pay attention to the one over there. Let's see what we have. Okay, n take away 2. Okay, I got a 2a plus n take away 1d, right? Now I'm going to rearrange that to write a plus n minus 1b. I'm just splitting up the 2a. The reason why I want to do that is because what do I have? I got a, which is the first term, okay, and I got a plus n minus 1b, which is, looking at it, is the last term. And that is another form of the series that we can use, and that is, okay, the series up to the n term, or the sum up to the n term, is basically the first term plus the last term divided by 2, or simply putting the average times by n. Okay, and there we go. The series can be written as, you got one form over here, another form over here, another form over here, and it is these that we use, or these equations that we use to solve arithmetic progressions. Okay? Yeah, hope you like it.